Number 13 through 16 is all about discriminant, describing the graphs of quadratics, etc., etc. The number 13, the answer was choice 1, imaginary. You have a couple of choices here, but regardless, you have to set this equal to 0. Anything with the roots, it must be set equal to 0. So I do the discriminant, where a is 5, b is negative 2, c is 3, and I get negative 56. Negative 56 is imaginary roots. Remember where that discriminant lives under the quadratic formula. It lives under a radical. If you have a negative under a radical, it will be imaginary. So that's a good way to remember it, or memorize that discriminant chart. Now, at number 14, the answer happened to be number 3, x squared minus 4 equals 0. You could have done this with back solve, or you could have done it by putting each equation into the calculator and seeing which one crosses at two distinct rational places. Could have done it algebraically. But the bottom line is that for roots to be real, rational, and unequal, the discriminant has to be bigger than 0, positive, sorry about that mess there, and a perfect square. So the best way to do this is to see where it crosses the x-axis, but if you want to do it algebraically, a is 1, b is 0, and c is negative 4, you would see that this particular quadratic gave me a discriminant of 16, which is a positive perfect square. Now for number 15, the answer was c equals 0. So they gave you a quadratic here, and a coefficient was missing. In this case, the constant was missing. So we can just work these backwards, I should say real. We can work these backwards and see which graph would be tangent to the x-axis, because roots that are equal, the graph will be tangent to the x-axis. Or better yet, just know that a discriminant b squared minus 4ac must be 0 when it has equal roots. So if you look at the quadratic here, a is 1, b is negative 8, c is c. And we're going to do b squared minus 4ac. And when you solve for c, I added 4c here, divided by 4. I got my 16 that way. I would check it by putting a 16 in here to make sure that it is indeed crossing the x-axis at one place, tangent to it. Number 16, the answer was choice 4, 2 distinct points with rational roots. We have this quadratic here, and you could have done this algebraically, once again, just like we did before. But I just want to show you something, the test feature, not the test feature, the zeros feature in the calculator. So if I put in the equation of x squared in y equals x squared minus 7x minus 60. Let's focus a little bit more on that. Sorry about this horrible camera work. And do a zoom 6. It's going to show me my parabola. You can see it's hard to see here because it's only crossing once. It's crossing a second time over here someplace. And if I do a second trace, which is my calc menu, number 2, the zeros feature, is really cool. It's going to ask you for left bound and right bound boundaries, and down here it tells me where I'm at. I'm actually at 0, negative 60 down here, someplace on the calculator, right? So I'm going to toggle left until I get to the left of that point. It should be right around here. So I'm going to toggle. You can see where I'm at. Oh, you got to be careful because it goes fast. There's my cursor. I'm going to hit enter, and now it's going to ask for right bound. Now right bound is actually below it. You're to the right of it. So toggle. I'm right bound now. See that? Hit enter. Guess. Who cares? And there it is. So you could see that that root happened to have been a rational root. Now, this is more useful if they were irrational roots. So I would definitely practice this. I probably would have just used the table here, because if you look at the table, if you look at negative 5, you will see a 0 there, right? So embrace that zeros feature.